In this video, we're going to look at the examples on the 1.2 slides. For these first few examples, we are asked to determine whether each sequence is arithmetic, geometric, or neither, and give the next terms. So coming back over here, we've got 5, 10, 15, 20, 25. Pretty clearly, this is an arithmetic sequence with a common difference of 5. So the next few terms will be 25 plus 5 is 30, 35, 40, and so on. For the next one here, we've got 3, 12, 48, 192, 768. So the difference between 12 and 3 is 9. But the difference between 48 and 12 is 36. So they don't have the same difference. This can't be an arithmetic sequence. The ratio of 12 to 3 is 4. The ratio of 48 to 12 is 4. The ratio of 192 to 48 is 4, and so on. So this is a geometric sequence with a common ratio of 4. So then to find my next element in the sequence, I would take 768 and multiply that by 4 and get 3072. Multiply that by 4. I've got 36,000. Okay, 3072 times 4 is 12,288. And we could go on from there, but I've run out of room there, so I'm not going to. Next, we've got 1, 4, 9, 16, 25. This is the sequence of square numbers. So the difference between 4 and 1 is 3, but the difference between 9 and 4 is 5, so that's not going to work. The difference between the ratio between 4 and 1 is 4, but the difference between 9 and 4 is 2.25. So this is neither arithmetic nor geometric. We can obviously find the next few terms here, 36, 49, 64. But it's not, and there are ways other than just squaring numbers to get those numbers, but it's not arithmetic or geometric. Moving on. We're going to look next at successive differences. And I didn't write this down. Of course I didn't. So we'll just write it down quickly. We're supposed to use successive differences to determine the next number in each of these sequences. A, we've got 14, 22, 32, 44. And B, we've got 5, 15, 37, 77, 141. All right, so we just subtract each of these numbers. 22 minus 14 is 8, 32 minus 22 is 10, 44 minus 13 is 12. And then we do it again. 10 minus 8 is 2, 12 minus 10 is 2. Well, then that means that to find the next number in our sequence, we add 2 to 12 to get 14. And then we add 14 to 44 to get 58. And there is the next number in our sequence. We do the same kind of thing here. 15 minus 5 is 10. 37 minus 15. Sorry, my brain is not entirely functioning today. It's 22. Yes. 37 minus 77 is 40. 141 minus 77 is 64. Repeat, 22 minus 10 gives us 12. 40 minus 22 is 18. 64 minus 40 is 24. 18 minus 12 is 6. 24 minus 18 is 6. So we add 6 to 24 to get 30. Add 30 to 64 to get 94. Add 94 to 141 to get 235, which is going to be the next element in our sequence. Next set of problems, we are looking at number patterns. And here we have a set of equations illustrating suspected number patterns, and we want to determine what the next equation would be and verify that it's indeed a true statement. All right, so we've got 1 squared equals 1 cubed. That's fine, no problem there. 1 plus 2 squared is 1 cubed plus 2 cubed. Well, 1 plus 2 is 3. We square it, we get a 9. 1 cubed is 1, and 2 cubed is 8, and we add those up and we get a 9. 1 plus 2 plus 3 is 6. 6 squared is 36. 1 cubed plus 2 cubed, we already know that is 9, plus 3 cubed is 27, which is 36. 1 plus 2 plus 3 plus 4 is 10. Squared is 100. Here we've got our 36. Plus 4 cubed is 64. That gives us 100. So the next element in this pattern should be 1 plus 2 plus 3 plus 4 plus 5 squared equals 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus 5 cubed. Okay, so on this side, we've got 100 for our first 4 terms, plus 5 cubed is 125, is 225. Okay, well, this down here is 15. 1 plus 2 plus 3 plus 4 is 10, plus 5 is 15, and we square that, we get 225. So there we go. That one works. Next up. Our next set of patterns, we've got 1 equals 1 cubed, 3 plus 8 equals 2 cubed. We can think about that for a second and see it's true. And 7 plus 9 plus 11 is 3 cubed. That's good. 7 plus 11 is going to be 18 plus 9 is 27, which is 3 cubed. 13 plus 15 plus 17 plus 19 is 4 cubed. Well, 15 plus 17 is 32. 13 plus 19 is 32. Add those together, we get 64, which is 4 cubed. Great. Okay, so the next one we see is going to be, we take the next 5 odd numbers, 21 plus 23 plus 25 plus 27 plus 29, and that should be 5 cubed. Okay, well, we already saw that 5 cubed is 125. Now, consider this. 21 plus 29 is 50. 23 plus 27 is 50. And 25 is 25. We add those together. 125 equals 125. We're good. Next up. All right, pages are clinging together. Here we go. 1 equals 1 times 2 over 2. Well, certainly 2 divided by 2 is 1. 1 plus 2 is 3. 2 times 3 divided by 2 is just 3. 1 plus 2 plus 3 is 6. 3 times 4 is 12. Divided by 2 is 6. 1 plus 2 plus 3 plus 4 we've seen is 10. 4 times 5 is 20. Divided by 2 is 10. So now we should see 1 plus 2 plus 3 plus 4 plus 5 equals 5 times 6 over 2. Well, certainly, we saw this before, that's 15. 5 times 6 is 30, divided by 2 is 15. All right, one more pattern here, and this is the most complicated one. Here we've got 12,345,679. Notice there's no 8 times 9 is 111,111,111. We are going to assume this first statement is true. And it follows that every other one of these statements is true. 12,345,679 times 18 is 222,222,222. And I'll show you why that's true if this first statement is true. Let's let 12,345,679 be n. And we have n times 9 is 111,111,111. Well then, n times 18 is equal to n times 9 times 2, which is 111,111,111 times 2, or 222,222,222. And this follows from each of these because 27 is 9 times 3, 36 is 9 times 4, 45 is 9 times 5. So if we take 12,345,679 times 54, that's equal to n times 9 times 6, which will be 666,666,666. Moving on. Now we're going to look at some stuff about, on page 18, we're going to use formulas to find each of the following, and then we'll answer some questions about these figurate numbers, triangular, square, and pentagonal numbers. So here we go. Here are our first three. We want to find the seventh triangular number. We use our formula for triangular numbers. T7 will be 7 times 7 plus 1 over 2. That's 7 times 8 over 2 is 56 over 2 is 28. The 12th square number, S sub n, S sub 12, is 12 squared, which is 144. The sixth pentagonal number, that's going to be P6, which will be 6 times 3 times 6 minus 1 all over 2, which gives us 6 times 18 minus 1 is 17 over 2. That's 102 over 2 is 51. There is our sixth pentagonal number. For our last couple of problems here, we're first asked to show that the sixth pentagonal number is equal to the sum of 6 and 3 times the fifth pentagonal number, and then to use the first 5 pentagonal numbers and successive differences to predict the sixth pentagonal number. We've already found the sixth pentagonal number, but we're not going to worry about that. We're just going to do it. Okay, so P6 we know to be 51, and we're saying that's equal to 6 plus 3 times T5, and T5 will be 5 times 5 plus 1 over 2, which is 15. Well, 6 times 3 plus 15, that's 6 plus 45, which is 51, so that works. Now we're going to use method of successive differences here. 5 minus 1 is 4. 12 minus 5 is 7. 22 minus 12 is 10. 35 minus 22 is 13. 7 minus 4 is 3. 10 minus 7 is 3. 13 minus 10 is 3. So I'm going to add a 3 to 13 to get a 16, and then add 16 to 35 to get 51, which we already know to be our sixth pentagonal number. That is it for this video. If you have any questions, please get in touch.